example, find the area of this figure. Lines that look parallel are parallel, dimensions are in inches. When they give you a statement like this, lines that look parallel are parallel, or maybe angles that look right are right, something like that, it's just for allowing you to assume certain things. Okay? The fact that these two lines have to be parallel because of that statement, I can't assume parallel lines. They look parallel, but unless they tell me they're parallel, I'm not allowed to assume that. This is basically the most challenging type of problem you're going to get in area, where you have to piece together certain different types of figures to find the area of each piece. And if we take a look, if I were to draw a dotted line right here, we're looking at a semicircle here. And then if I do another dotted line right here, we're looking at a rectangle right here and a triangle right here. Okay, and again, triangles, rectangles, either circles or semicircles. Usually in a figure like this, there's going to be a semicircle involved. Yep, what? Well, we can figure that out in a minute. Okay, so, and Parker already figured out something that we have to worry about. What's the height of the triangle? What's the height of the rectangle? And what you have to do is use the information of the problem to figure it out. So, this is a radius here. This is the center of the circle here. So, I've got to go 2 spaces up or 2 spaces down from the center. That tells me the length of that's 4. And since these are parallel to each other, that's 4, so this must be 4 also. Okay? Because I drew those in such a way they had to be right angles. You can't assume right angles, but know that right angles would exist in that figure. So I'm just drawing those so they are right angles. So they're going to be. Alright, so those are both 4. That's 5. This has to be 5 here, right? From here, from here all the way to here is 5. Which means since that's 7, this piece right here would be 2. Okay, so that's what you're going to do on a problem like this, is you're going to figure out dimensions of all these figures in order to find out the area of each thing. And then for each different figure, you have to use the correct formula. For a semicircle, it's the same area formula as a circle, except you have to divide by 2, because it's only half a circle. Okay, that's not the same as pi times r. You have to square the radius times 3.14, then divide by 2. So in the case of this, it's going to be 3.14 times 4 divided by 2.
So could you just do 3.14 times 2?
In this case, it's 2 because the 4 divided by 2 equals 2. But again, I've seen people just try to go pi r instead of pi r squared over 2. So be careful. In this case, since the 4 divides evenly, it just comes out as that. That's a coincidence in this situation. But so square the radius. Again, I square the radius mentally as long as it's a small number. The radius of some large number or some like decimal or something, I'd probably use a calculator. If you do 3.14 times 4 divided by 2, you get 6.28 for the semicircle. If you look at the rectangle formula is length times width. The length of the rectangle is 5, the width is 4, so it's just going to be 5 times 4, which is 20. We consider the triangle. Area formula of triangle is base times height divided by 2. The base is 2, the height is 4, so it's going to be 2 times 4 divided by 2. It's just 8 over 2, which is 4. So I've got a semicircle, I've got a rectangle, and I've got a triangle. I figured out all 3 areas. All 3 pieces combine to make the figure, so we're going to add them all up in order to get the area of the whole figure. 6 plus 4 plus 20 is 30.28. And it is area and dimensions are in inches, so it's going to be inches squared. Alright? And again, that's probably as challenging a problem as you're going to get at this point in time. No matter what figure you get, whether it's this type of figure, if it's a trapezoid, which I didn't get any trapezoids up here, but suppose we had a trapezoid. There's a trapezoid. Like so. You can do several things with a trapezoid. One thing you could do would be to draw this line down like this line down like that. You get 2 triangles in a rectangle. Another way of doing a trapezoid would be to do that. You get 2 triangles. Alright, that's another way of doing a trapezoid. If you did the 2 triangle technique, that blue line is the height of both triangles. You got a base and you got a base. So 1/2 times base times height for this one, 1/2 times base times height for that one. Alright, take your pick. The 2 triangle method doesn't make sense. Do the rectangles and the triangles. Alright?